Hi everyone, so here we are going over the key for our chemistry assignment. So the very first section we're completing out of the periodic table. So the first one is atomic number 63, so that's going to be europium. And we'll look at europium. The symbol is Eu. 6, it's a solid, and it's in the family of the lanthanides. The next one, I sort of look at it like a map. I read it like a map. So group number, so these are my columns. I'm going to look at column 17 and row number 5. And what I see that's iodine. And it's number 53. The symbol is I. And iodine is also a solid. And it is in the group of the halogens. What is the only liquid halogen? That would be bromine. Number 35, Br, and it's again 17 and 4. And the last one, krypton, and it is a gas, and it is in the noble gases. Here I have to look at the atoms and ions. So the very first one that I see over here is an atom. So atom means that it's going to have the same number of protons and the same number of electrons. So when I look at sodium is number 11. So if it has 11 protons, it's going to have 11 electrons. It will have gained and lost nothing, and therefore it won't have a charge. Okay. The next one is number of protons is 9 and number of electrons is 10. So I know it's an ion. It is fluorine, but fluorine changes to fluoride ion. And so I'm just going to put the symbol as F for now. It has 9. Remember that these are the positives and these are the negatives. So I have one more negative than positive. I have 10 of these and 9 of those. So if I have 10 negative and 9 positive, I actually end up with a negative charge. So I'm going to put a negative charge. That's the charge of -1. So it's supposed to have 9 electrons. It has 10, which means it gained 1. Okay. This is sodium, again, ion, so it's not going to have the same number. So I'm just going to write down Na for now. Sodium is number 11 in our periodic table. We just saw that. But when I look at sodium is got a charge of +1. So +1 means it has one more positive than negative. It has one more of these than these. So if it has 11 positive, it only has 10 negative, which means that it lost 1, and that's why we get the +1 charge. Number 20 is calcium. And so don't forget that. For sodium, we get to put the +1. Calcium, so again, I'm going to write Ca. We see that it is an ion because it has a different number of protons than electrons. It's supposed to have 20 electrons, but it has 18, which means it lost 2, and its charge is 2 positive. So that's what we're going to put there. The isotopes table, this is carbon 14, which means the mass number is 14. And what is the atomic number for carbon? When I look in the periodic table, carbon is element number 6. And then don't forget that your mass number is your protons plus your neutrons. So what is my number of protons? The number of protons is the same as your atomic number. So those two numbers are going to be exactly the same. So since I have, for example, 92 here, I'm going to have 92 there. Since I have 2 here, I'm going to have 2 there. And since I have 90 here, I'm going to have 90 there. All right, so that's part of my table is already filled out. Okay, so then if I have 6 carbons, for numbers of 6 atomic number for carbon, then the number of protons is 6. So when it comes to the neutrons, since the mass number is the protons plus the neutrons, if I have 14 minus 6, that should give me 8. So if I take the mass number minus the protons, that gives me my neutrons. Okay, so here's number 8. Over here, so the opposite is also true. If I have 146 neutrons and 92 protons, if I add those two together, I'm going to get my mass number, which is 238. Okay. 2 protons right there. I have a mass number of 4, and therefore 2 plus 2 is 4. So that one's 2. 90 plus 142 is going to be 232. So I have that part of the table also filled out. Okay. Now it comes down to the name. Where do I get the name from? That's where you get the name from. So 92, element 92 is uranium. And I'm going to put the dash and then the mass number. So that's uranium 238. Number 2 is helium. Helium dash, my mass number is 4. And then number 90 is thorium. And the mass number is 232, so dashed 232. Okay, so that's that one. For the next part, what we gotta do is we need to look at our Bohr diagrams. So for this one is gonna be a magnesium atom. So I have 12 protons. Since it's an atom, I have to have the same number of electrons. 2 in the first energy level, 8 in the second, and 2 more for a total of 12 in the third. Okay. This is a nitride ion. So it has 7 protons. Okay, so this is magnesium. This is nitride. N3 negative. So what the 3 negative tells me is that I need to have 3 more electrons than protons. So if I have 7 protons, I should have 10 electrons. 7 plus 3 is 10. So I have 2 in the first and 8 in the second. That's 10. Okay, so here I have 10 negatives, 10 electrons, and 7 protons, which gives me a -3 charge. Okay. Write and you don't need to have any of this for your answer. You just need to have that. So write the formula for the following ionic compounds and the correct states. All right, nickel 2 nitrate. So I'm gonna need nickel and then nitrate and 2 and an S. How did I do that one? So I have nickel is 2 plus, nitrate is -1. So if I put it on a teeter-totter, I'm gonna need another nitrate right here. So I need 2 nitrates for every nickel, which means I'm gonna put these in brackets and then put a 2 on the outside. Okay, sodium chloride, NaCl, all ionic compounds at room temperature or SATP are going to be solids. Calcium iodide pentahydrate. So I have calcium and iodine. And you can say, okay, calcium is 2 plus, iodine is 1 negative. So I'm gonna need CaI2 and then pentahydrate. So I need 5 waters. And then again, it's a solid, so I'm gonna put a solid after it. And then potassium sulfide, K and S. Again, K is +1, S is 2 negative. So I'm gonna need K2S with a solid on the outside. Okay. Write the names for the following compounds. So the first one, I have sodium nitrate. The next one I have iron, but when I look in the periodic table, I have 2 options for iron, so I have to figure out which one it is. Well, I have a 1-to-1 ratio. On the teeter-totter, I have 1 of each. This one is 3 negative, I can tell in the periodic table. So in order for me to have a 1-to-1, this one must be 3 positive. So that is iron 3 nitride. Next, again, I have CuSO4. So if I put that, I have only 1 Cu and 1 SO4. SO4 is 2 negative, which means this must be 2 positive. And so it is copper 2 sulfate. And zinc only has the 1 charge, so I don't have to worry about anything in brackets. So that one is just going to be zinc phosphate. Okay. And again, why is it like that? Zinc is 2 plus, phosphate is 3 negative. So I'm going to add another zinc. That's 4 and 3, not good. That's 6 and 4, not good. Now I have 6 positives and 6 negatives, so there's my formula. I need 3 of these guys and 2 of these guys. Write the formulas for the following compound. These ones you should have found in your periodic table in your data booklet. So water is H2O liquid. Methanol is CH3OH, it is also a liquid. And octane is C8H18, and it's also a liquid. This is the stuff that goes in your car, okay? Then here we're writing the formula for molecular compounds. Remember that molecular compounds use prefixes. So I have silicon, one of them, but then I have dioxide, so I have 2 of those, and it is a gas, okay? I have carbon, so 1 of those. Monoxide means I only have 1 of those. Sulfur, okay? Dichloride, so again, I have 2 of those, and it is a gas. Write the names of the following molecular compounds. So I have 1 carbon, so it's carbon. And there's 3 chlorines, so it's trichloride. Here I have nitrogen. And I have 2 oxygens, so dioxide. And here, careful, because a lot of you guys gave me potassium, but that's actually phosphorus. And I have 3 bromines, so tribromide. Okay. Next, what we have is balancing our chemical reactions. And so for balancing our chemical reactions, our first reaction, what we see is we have 2 Cl's, only 1 Cl over here. So I'm going to put a 2. Now this 2 has made that into a 2, so I'm going to need a 2 over here. So again, 8 S's, only 1 S here. So I'm going to put an 8 in front. Now I have 8 irons, so I'm going to need 8 irons over there. Water, so this is a decomposition of water. So I have 2 oxygens over here. I only have 1 here, so I'm going to put a 2 in front. This has now changed that into 4 hydrogens, so I'm going to need 4 hydrogens over here. Okay. And then I'm going to go to the next one, and I have 3 sulfurs, 6 hydrogens, I need 6 hydrogens, 6 Cl's, I need a 2 there, 2 AS's, I already have 2 AS's. Next one, I have 3 of the ammonium, so I'm going to need 3. That changes and gives me 3 hydroxides, so I'm going to need 3. This changes and gives me 3 hydrogens. I already have 3 hydrogens, 1 phosphate, 1 phosphate. And then finally, we have a hydrocarbon combustion, which we solve using the Cho rule. So we're going to balance our carbons first. We have our hydrogens are next. I have 8, so I need 4 times 2 is 8. And now I'm going to add my oxygens. 3 times 2 is 6 oxygens and 4 here. So I have 10 on this side. I'm going to need 10 on that side. Include the correct states of matter and state the type of reaction for each question. So octane reacts with oxygen. That's a combustion reaction. Aluminium oxide breaks down into the elements. That's a decomposition reaction. And chromium reacts with magnesium sulfate. I have an element plus a compound. And so if I have an element plus a compound, that's a single replacement reaction. So I have that done. So now I can just start by writing out my skeleton reaction. So octane, which we saw earlier, reacts with oxygen. And we know that whenever we have a hydrocarbon, the elements of the fuel are going to combine with the oxygen to make oxides. So carbon and oxygen makes carbon dioxide gas. And water vapor for the hydrogen. Okay. And then I have aluminium oxide. So aluminium is 3 plus, oxygen is 2 negative. So I have Al2O3. solid, is going to break up into its elements, which are aluminium and oxygen. Oxygen, remember that when it's written by itself, it's diatomic. So I'm going to write down O2 gas. And then the last one, I have chromium, which is a solid, reacts with magnesium sulfate. So magnesium is 2+, sulfate is 2-, so that's a 1-to-1. So MgSO4. Here I'm going to have to check my solubility. So I'm going to go into my solubility chart, and sulfate magnesium is aqueous. So I can put that there. And now I have a single replacement reaction. This is a positive, or a metal, this is a metal. So these guys are going to switch. And so now the magnesium is going to end up by itself. And the chromium is going to go with the sulfate. So I'm just going to write it down like this. But I want you to see that in the periodic table, chromium is 3+ and sulfate is 2-. So now I'm going to have to do crisscross. So the 2 goes here and the 3 goes there. Checking the solubility for sulfate and chromium, we are still looking at aqueous, and so I'm just going to put AQ there. All right, now it's time to balance all of these guys. We can't leave it like that. They have to be balanced, so I'm just going to choose a different color here. So the first one is hydrocarbon, so I'm going to start with my carbons. So 8 there. 9 times 2 is 18, so that I got that. And then 8 times 2 is 16, and 9 is 25, so I can put 25 over 2. Some of you multiplied the whole thing by 2, and that's fine. If you did, you would have gotten 2, 25, 16, and 18 there. So that's also correct, okay? And the second one, I have 2 oxygens on one side and 3 on the other. The lowest common denominator is 6. So 3 times 2 is 6, and 2 times 3 is 6. And now my oxygens are even. And then 2 times 2 is 4 aluminiums, so I'm going to need 4 aluminiums there. And lastly, this last equation, what I see here, I have 3 sulfates on one side. I only have 1 sulfate on this side, so I'm going to need a 3 there. I'm going to need a 2, I have 3 magnesiums, so I'm going to need a 3 magnesiums there. And then I have 2 chromates here, so I'm going to need 2 chromates there. Or chromium, not chromate. All right, so that is it for the assignment. The biggest one was this one at the bottom. Obviously, knowing how to do this is what's going to serve you well in Chem 20. You need to be able to write chemical equations and balance them and know the different types of reactions. So make sure that if you still have questions on this, that you sort of ask either me or your teacher next semester, next year on how to do this, because it's super important for stoichiometry and for Chem 20. Okay, and I will see you guys tomorrow at our Google Meet.